Hey guys, how's it going?
Hey,
Hello. Whoa, you got some nice glasses there, Barry.
thanks, man. Going for the Web3 look.
Amazing, amazing.
Yours are good too, actually. I'm not too bad. I think we're matching the style.
Gold rim aviators here. Um,
Exactly.
yeah. Hey Bertrand, how's it going?
Good enough.
Very
We
nice.
have done some vibe fixing.
Yeah, we're debugging live.
Debugging live.
As
That's
a
the word.
debugging live, dude. They say vibe coding, but in reality, it should be called vibe debugging because
That's
that's
how.
like 90%
Yeah.
of the time. That's what it is, isn't it?
Yeah.
Um, Yeah,
Cool.
the LUKSO, the squids were prepping, and yeah, we just were running into like some challenges on my machine, especially because like I had like some conflicts with Docker and stuff. So Bernard will be probably presenting this one, like in terms of like the just kind of showing the demo and like how everything works stuff. But yeah.
Cool. Cool. Sounds good. Well, let's kick things off. Thank you everyone for tuning in live. You could have been anywhere in the world, but you're here with us. So we appreciate that and hope you find this helpful. Now, to give context, today's a special session for the SQD and the LUKSO builders community. In case you're tuning in for the first time, LUKSO is a creative playground or EVM network if you prefer, with a suite of innovations around account profiles and standards, the combination of which allow builders to unlock their creative potential when it comes to building use cases and applications around social culture and creators. Now, thanks to Bertrand here, who's on the live stream today. He made this integration happen, and SQD recently announced the integration of the LUKSO chain, and that's what, at the end of the day, today's session is focused around. Educating builders around the indexer framework and SDKs that SQD provides to builders, and hopefully it helps all the builders in the ecosystem, on their journey to build cool DApps on LUKSO. So I'm going to hand it over to Barry from SQD and also Bertrand from Green Pill Dev Guild, and then we'll dive right in.
All right, fantastic. That was a nice intro. Thank you. Yeah, so I'm Barry, but also IRL Alex. So yeah, I'm a DevRel at SQD, and I'm also pioneering, spearheading the SQD Boost program, which is basically like ecosystem establishment, expanding the ecosystem of like the squids and like the future products, so that people can onboard like much quicker. So it's basically like we're designing a set of modules. So say you're like on LUKSO and you want like a social module, you basically import it into your squid, and you can like use the data. It populates your Postgres. It's really easy to use. Yeah, before SQD, I was working for Unicrypt. I was an engineer there for about 4 years, and I started as a backend engineer. Yeah, so I just kind of been through the trenches, I guess. Yeah, of the old bull cycle. Yeah, it was quite an exciting time because ETH was the main chain. Everything was launching on ETH, and then you started getting Binance Smart Chain, all these other chains that were like much faster and much harder to index, and we started feeling like the kind of the limitations of the indexing solutions and things like this. So yeah, to begin with, I just wanted to show share my screen real quick and show what SQD network is.
Before you jump into that, Bertrand, do you want to give a quick just for context as well?
So thank you for hosting us and for this idea of live demo. And so, yeah, wanted to show that SQD is working on LUKSO. And so, yeah, I was feel it's helpful to have this kind of different alternative for the indexing on LUKSO, and to see which one also integrate better with the different standard of LUKSO. That will be the, and so that's Evie also showing that this is the initial presentation to prepare for a more advanced presentation later, where we will do it for a LUKSO community project. We need this, which needs this indexing to solve issues like latency issues on this data.
Amazing.
Okay.
Yeah, go ahead, Barry.
Take it away.
Yeah, I'll wait. Yeah, I just wanted, I have like a few, I did like an Excel draw, kind of like showing like what makes SQD special. Just kind of wanted to like present it to the guys. But basically, yeah, we just want to chat about, you know, how to, they want to chat about how to fetch the data, how to transform it, how to query it. Because you know, SQD is a kind of a very powerful platform. I like to call it, you know, like a second generation indexer, basically, where you can index like multiple chains at the same time, and like extremely fast chains, you know, and sync it with your database. So basically, if you want to create like very powerful dashboards, like it's perfect for that. And yeah. You know, AI apps, social apps, it's like perfect for that. And yeah.
You guys have been doing quite a large push on the AI agent side of things, right?
Yeah.
In terms of that vertical. Yeah. Yeah.
Okay. Yes. Yeah, we have been doing. So basically, 1 second. Sorry, I'm just trying to present. Okay.
No worries.
Yes. Yeah. So on the AI side, we've been. So this is what the SQD Boost program is about. It's basically like us trying to. There is definitely like a void of just interfaces and like APIs that you can query. There is a lot of like AMM data, but it's also very unorganized. So what we kind of want to do is create a unified experience where you can index like a bunch of AMMs at the same time. Very useful for like, you know, staking apps and such, especially if you're multi-chain. You know, you have like multiple Uniswap protocols, you have like versions, you have obviously multiple chains, and that's like, you can imagine this is like in the traditional classic indexer sense, it's like, how many indexes is that? It's like 20, 30. So the idea is to basically simplify it and make indexing like a lot easier to use, and ideally bridge the gap between EVMs, Solana, etc. So let me share my screen real quick.
Amazing.
Okay, can you see my screen?
Yep.
So basically, what is SQD? It's a data like warehouse, which so we collect data from, for example, LUKSO, Ethereum, Solana. We ingest this data and we process it for very fast retrieval. So this allows for basically like, this is basically the core idea behind this insane performance. Traditionally with RPCs, you would have to, you know, query each, go like step by step, just query like a range of blocks, and it would take like months to sync. So with SQD, it's just like you can sync it pretty much, you know, what took months before, you can sync it in minutes. So on top of this ingestion layer, you have the worker layer. This is a decentralized system of workers, and they basically stream like chunks of data, and they distribute it through a decentralized gateway layer, basically. And that's where the basically squids come in. But you can query the gateway directly, but squids are basically like the primary interface right now to get access to this data. And then you can basically, query IPFS. You can call the APIs during syncing. And obviously, like the default interface is GraphQL. So it's very compatible with, like the established interfaces like the Graph. But it's completely modular. So the nice thing is like, this is not, this is not a monolith. You can basically like self-host it. You can split it up. You can change the database. It's very flexible, like very performant, very flexible. And we also offer like a cloud solution, so you can host with the cloud. So it's pretty much like in a few steps you can just deploy it. So as I was saying before, you grab a template. So we have templates for example, like ERC, EVM logs, transactions. Like we have a lot of different templates. We also have Uniswap, different Uniswaps. V3 and V4 coming out, so you can basically, if you have like an AMM and you want to use the Uniswap interface, you can just import it as a module and deploy it to the network. So what makes SQD basically different from, like the V1, the old type of indexer? So this is like 2021. Right, this is like a lot of apps. This is what we basically did. I mean, nowadays it's also fine, like you create the apps. It's totally cool. So you have a tab, and say you want to query, like you want to get historical data. So say you have like a social media profile, and you want to query like all the tweets, and like you want to do like historic analysis. So the way you would probably do it is you would go like block by block and call the RPC and like query the contract. So like the contract would have the like a custom API, and then you would custom getters, and then you would call them, get IPFS hash, do all that, and yeah, you can imagine this is extremely slow. This is like if you have like a few posts, it's fine. Like if you have, I don't know, 1,000 posts, this is going to take you like maybe an hour. I don't know. It depends. Maybe like 10,000 posts is like hours, right? So this is where like indexing V1 comes in. So this is like the traditional like indexing solutions. For example, the Graph protocol is a good example where it's you batch, like you index the events, and basically you is deterministic, but it's also like a monolith, right? It's very isolated. It's like a whole experience in one package basically, and you can't really do anything about it. So it's slow. So if you were syncing Uniswap, for example, right, it will take you months to sync. But with the newer solutions, like it's totally painless. It's like 2 minutes, right? It's crazy. But yeah, it's self-hostable, but obviously it's not ideal because, like I mentioned before, like say you have like 5 chains and then you have like multiple Uniswaps. You have to deploy basically an indexer for each one of them. It's not ideal. Then you have the Squid SDK, which is I call it V2, the second generation indexer, but I just like totally my thing. And it is backed by this decentralized data lake archive, which basically allows you to query this data like at a really fast speed. And this is what's like backing this technology. So basically this decentralization goes from like the indexer level to the worker level, right? And it allows us to do like some really cool stuff, like multi-chain. You can self-host, you can change APIs, you can do whatever you want basically, and you can host it with the cloud. So yeah.
Amazing. So Definitely useful to help developers, query data much quicker than the V1s and the V2s in the past. Just a question, when it comes to querying, if the DApp is cross chain and it's querying data from different chains that's connected to SQD, how does that work from the developer's perspective? Are they querying the data through kind of like one unified API, or do they have separate ones? Just curious from that perspective.
Yeah, it's pretty straightforward. So you have the squid YAML, and you can just basically define multiple processes. And you just define them here. And this is an example of like multi-chain squid template, right? And you can go into source, and so you just define multiple processors, and off you go.
Cool.
But yeah, it's worth playing, especially on EVM if you if you want to combine like AMM data. It's pretty cool.
Yeah, that's
we also have like sorry. We also have like
AMM on LUKSO universal swaps.
Yeah.
I'll definitely forward the docs to them. Yeah, they'll be interested. So amazing.
Exactly, and we'll be building like a lot more templates. So so like we said, like for us, it's really important to cover the base layer of the chain. So like what's most important for it, like the social. So for example, for LUKSO, maybe like the social apps are like super like high importance. So we want to build like social an ecosystem of like, well, just modules, I guess, a set of modules that index like social media apps, and later you can, like, this is the powerful thing, right? You can combine data from Uniswap, from LUKSO. You can mix and match basically in the same database, and create really powerful products like this.
Yeah. Very cool.
Yeah. But yeah, it's very powerful. So with indexing, so with the older basically indexing technology, it was really difficult to index transfer events. Nowadays, it's people are indexing Solana. Solana is still a struggle, but it's I think we get like it's going to be figured out fairly soon, and basically like indexing transfer events of tokens and just all this data, it was just like it felt like it was impossible like a few years ago. For example, I mean, it was possible, but there wasn't like any solutions that allowed you to build like a custom like indexer on top of it, if that makes sense. So that's why it's so exciting.
And then in terms of the differences in speed when it comes to syncing up to a particular network or calling data from the chain, what are some of those kind of relative comparisons between SQD and I guess the more traditional methods?
So I would say that we were testing Uniswap before, and sync times were I would say months. Like before, if you deploy it on the say subgraphs, for example, it will take you like a month. By the way, the graph has like excellent product, which is also substreams. So with substreams you can actually like bridge the gap there, but it's but I would say SQD offers like just such a nice and easy to use interface that with the same performance gains pretty much, that it's an obvious choice, like for me. Like 2 minutes, I think that's how long it took us to sync Uniswap before, like on ETH, and that was like, it's really powerful.
Okay. Nice.
Oh, sorry. Okay, I'll stop sharing for now.
Cool.
Yeah.
Bertrand, I think you were interested in doing sort of like a vibe code session should should we still dive into that, or did we want to save it for, because there is a project on LUKSO right now that's integrating or building an application on LUKSO and then integrating with SQD, and that's quite live at the moment. So quite soon we're going to be able to hop on again and really dive deep into how they're utilizing SQD's technology. But yeah. Yeah.
That's why we have prepared a basic demo for today to not confuse too many people. So as Alexander explained, like just indexing the transfer of the like token that is created by Forever Moment. And so this will show also that instead of indexing the ERC20 token transfer, as usual in Ethereum or EVM chain, here we are indexing the LSP7 transfer just by updating the API from the example shared by SQD in GitHub. So whenever you want, I am ready to share my screen to Raven. So we do it in public. Like it's more live coding than vibe coding this time, but next time I think if Barry want to try something, but I guess we are not ready this time for the vibe coding. But for next time, I think we will we'll use some LLM to see how the LLM are adapted already to SQD. And so or you can ask LLM to update a SQD template to do whatever you want to do. So for example, what we have done manually this time, we could check with which LLM which can do it automatically for us. So without, they say, having a man in the loop, at least just having the man reviewing what has done the AI. And now with good tooling, you can even, I have not tried it yet, but you can even speak to the AI. And so with your hands on the screen, you can say whatever you want, the AI do it for you, and you just have to validate what is done. And if you are lucky enough, I feel it's more like also when Google has started with this I feel lucky button on the search. Now we are using it more also in this way that you feel lucky enough that the LLM will understood you enough to do what you ask it. So and there is even even a French open source, French, at least a French naming open source project that is called Aider, in French Aide, but in English I would say Aider. And I've tried it last weekend to try to make it fix automatically some TypeScript errors. And I was happily surprised that it fixed without any loops also. Because usually in LLM, you can have some loops that he doesn't understand you correctly. And so it proposes you something, and you say, no, that's not what I want that, but then it proposes you something else. And here, that's what I like, it's that you are kind of a layer 2 of AI, because you have you ask the Aider CLI, and the CLI asks the LLM for Git commits. And so this way also, you have a kind of atomic Git commits for every change done by the AI. So it's also easy to roll back, because that's also a big issue still in LLM proposition, is that you have something working, then you ask something else, and then it breaks everything because it didn't understood what you wanted. And then if you have not pushed it to Git first, sometimes it could be complicated to go back to the working status. So I feel it's also a matter of integration. Yeah, but to keep it simple today, you feel ready for the live demo?
Let's do it.
Let's say let's build in public.
Let's do it. I love how
So-
Bertrand's always so deep into the sauce. Literally
And
on the
let's see if it will
Yeah.
work. Because I mean, to be fully transparent, we tried it just before, and I've tried it with a different Linux user on my Ubuntu laptop, and now I will redo it from the other Linux user, and so do it from scratch, and to show you that that it's not a fake demo, that we have done everything before and it just worked before. Now we redo it from scratch.
Let's do it.
Let's try to share my screen.
Let's go. Yeah. So to just kind of like do an overview, what we did basically is we took the USDC swap transfer SQD, and it's like you know, like on USDC on ETH is a ton of transactions, right? And you know, the sync times are pretty incredible. Like this is like really hardcore data, you know, like it would take takes a long time to sync usually, but you know, we went through it very quickly, and we took that and we adapted it for the LUKSO ecosystem. So we replaced the APIs, the yeah, I'll let you take over.
No, sure. I mean, we can even try to redo it fully, but to show you how it worked, I mean, I could show you first the expected output, and then we'll see if we can get it again. So we started with this repository with this needed update. So we updated the ABI because ERC20 is not the same ABI as LSP7. We have done. We'll do later. We need some database migration for the local database that stores the data lake. Okay, here we change the naming in the GraphQL schema. Yeah, that's also the ABI that was generated from there. And then also this is what is generated also for the model of what we want to index. So in our case, we want to index all the transfer of the like token emitted by Forever Moment. So for example, when you swap leaks to like token. So starting from, and it's the start is this part. So we just have, if you want to reproduce it, you just have to go to this page, like docs.SQD.ai, and then going to indexing SDK and quick start. And so what I've done first is to install the subscript CLI. So that's what you see here on this one. So here, this one. So I got first I'm using NVM, so I switched to version 22 of Node. Then with this command, I've installed the CLI, and then I've checked that it provides the SQD binary. So that's the first part. Then we scaffold the indexer from an example. So it's already, you can do it with this SQD init. And here you name the directory where you want to store it. And here with the -t, you select the template you want to use. Here we use showcase 01 OLUSDC transfer. and then we enter the directory. So that's a kind of what I've done here when I've cloned this repository that I've already the change made, so LUKSO transfer demo, and I verify with Gitlog that I got the last commit, which has the LUKSO update. And this one is, so it's only the one commit I've shown you. Then it's, so we can inspect, like here, we can inspect the SRC folder. So yeah, with even 3. No? Yeah, well, you will see this. So like that, what I've shown you in the commit difference. So we have the ABI, so application binary interface to be able to connect to the contract to understand the event. Then we have the main.ts TypeScript file to where we will configure the processing. And then we have all of this is when it's code generated, it will be generated by the command codegen. Yeah, it's explained. Yeah, so doing the typo error, it will auto-generate. It will generate automatically from what we define in the schema with the GraphQL syntax. So the biggest part to change is to set the gateway and to set the RPC endpoint to LUKSO, to the LUKSO part. So if we, it's in the main TS. So we could even do that web minus LUKSO in SRC main TS. And here you will see that we got the set gateway here with the gateway provided by SQD for LUKSO mainnet. We got the RPC endpoint adapted to LUKSO. And then here we have the contract address of the like token on LUKSO, which is used here. And then from this archive and RPC endpoint, by connecting to this contract address, we need the ABI that we put in this ABI directory. And then we check the topic of every event generated by this contract. And we say we want only the transfer event, and we pick this topic as topic 0. And then that's really explained later. That's what we want to get from the log of this event. So yeah, you see it there. So instead of indexing USDC, we index the like. Yeah, so that's the main part to look at. So what I've shown you here, the address and topic 0. It's explained in the command. And then the rest of the file is about data processing and storage. So it will process what is already available in the archive. And then for the latest block, it will use the RPC. That's what makes it much faster than having to query always the RPC. And it creates also less load on the RPC. That was a big issue with the initial subgraph, because you require an archive node, and then you need to create the archive node for all the history, for all the blocks since the blocks where your contra was deployed. Here it's much faster. So that's what is done, and yeah, that's what we want to save in some way. Like so, we define the transfer variable. We connect to our local database, which is in this case a PostgreSQL, which is started by Docker. And then for every block in the context that we run from that we get from SQD, we look at every log at every block, and for every log we look if the log address is equal to our LUKSO contract address, which is a like token. And we look if the topic 0 of the log is equal to the transfer topic that we want to index. So that's what we get from the API. And then if we pass this in these two conditions, we enter the if, and we decode of this log to get the from, to, and value variables from the log, and we push in the transfer variable that we have a new transfer of like token, and that's the mapping of data we register. So the ID we will put, it's the ID we get on the log. The block is the block.header.8 that we got also from the log, and then that's from is the same name, so we don't need to precise. The same for to and value, and the TX hash we get from the log.transaction hash. So here you just have to map what is available in the log of your event and what you want to save into your database schema. And you loop with all these two for loops. And at the end, we insert we insert per batch this transfer array into the store of the context, so into our local database. So that's what we program in TypeScript instead of having to program in WebAssembly, as in subgraph. And then when we have programmed all this, so that's where I'm going to run it locally, is that we have to install the dependency and build. So that's where I got it there. And yeah, that's not, let me put it here. That's yeah. So we should have the same than this. So we will install the dependencies with npm CI, which is a clean install instead of just an install. Yeah, so we got this number of package added. Then yeah, we do so we can use SQD.ai, which is done. We'll do the same than Docker Compose at -d. So because that's what is configured for this repository, so it's kind of a make command that you to make it simpler to type SQD.ai instead of Docker Compose up -d. Maybe here I need to, if I don't want it to crash, I need to stop it from this other part. So here I need to do SQD down, if it exists. What I was running on the other Linux user, and I'm running it there. So SQD.ai, it will run from my BERT user. Yeah, because on this one, I guess I need to, it's not, I need to reload it. So let's do it. Which SQD? No. Yeah, because it's in 20. That's why. So let me do it there first. So here I have SQD and so SQD app. Yeah, so here you see the network has been created and the container has been started. And so it starts the demo DB, so PostgreSQL from PostgreSQL Docker container. So it provides the database connection to the SQD processor that we will launch after that. That's it. So we have started the SQD app. And after that, so here that's how it worked. Then we do the code gen to do the generation of the ORM. And after we launch the GraphQL server at the end. So here, SQD code gen. Yeah, here I will have to, okay. Maybe I can even share it like this. So this is how it worked, and this is me redoing it. Up. Yeah, and you see here I'm doing it with the latest version of SQD CLI, and here with an older one. So I got a warning to make me to inform me that an update is available, and explain me how to update it. Okay, so here's code gen has generated into SRC the generated part. Here, like if you see here, it has been updated. And now, after this SQD code gen, I need to run this SQD migration generate. It will generate PostgreSQL migration to initialize the table of the database. For the type ORM we generated just before. So here it generates the like object relational mapping ORM, and then we use what we generate to generate the table, the migration to then execute this migration in the database. Yeah. And here you see, should see the same. So it has a clean, build, migration clean, and migration generate. And now that we have the database ready, we can start processing. So to start processing, we just run SQD process. And so don't close the eyes because it will be really quick. See, clean, build, migration. So it applies the migration, and then it has already finished to index. So it has indexed first from the archive up to this block, and then it has switched to the RPC data sources from this block, and then every new block is automatically detected and indexed. So you see, it has all this block to in the archive. So it has indexed as this speed of block per second, and so it was mapping this block per second, and he found this number of items per second. And when you have a lot to index, you have a kind of a DTA. For example, if you run USDC on Ethereum, we had an ETA of 1 hour. Here, because we have done it on the on the LUKSO, it was pretty fast. Didn't need any ETA, and so that was the archive part. And then to get it real time, then we switched to the RPC that we put in the variable we set before. And now that we have this indexing done, we can run the GraphQL playground to do the GraphQL query to check if we get our expected results or not. And so that's where we do the SQD serve. So here you could do the same. You could see the same. He has done the migration first. That was automatically generated. Yeah, that's for this. That's it. And now here I just need to nvm use v22 dot this one like node -v. That's this one. This one. Yeah, 22 minus 15. Yeah, and now if I do which QT, you find it because of NGM. And so, and now I can do SQD serve, and it will start the this subscript GraphQL server. That's where you see this this screenshot. Yeah, and it's listening on this port on localhost. And then step 7, query the data. So I open it here with /GraphQL. I check, yeah, and it works. So here we have the different collection. We can check the SQD status to see which is a finalized 8, which is a finalized hash, and this kind of thing. So yeah, here because I put like this. So here you see that the 8 is this, and he has a finalized 8 there. So there is always a delay between the finalized 8 and the 8. In the same way with the hash. So that's how you can check the progression of your sub-SQD status. And then when we want to find our transfer, we can ask to the block number, so from the 2, the detection hash, and the value, just by default. And then we get automatically all the data that we indexed. So here, for example, when you have a from that is all 0, it means it's a mint. And so this value with all the decimals included has been minted to this address at this transaction hash. And so I can copy this transaction hash and check it in the Explorer. And you will see that here, that's when the contract was deployed. If you look at the logs, and then if you search for a transfer, here we could look at the token transfer also, but here in transfer, here we see the transfer that was the same, that was minted to this address. And so if we check the amount, we can look at this amount here and see if it's, and that's the same amount here. And even for the address, we can take the address and see it's there. Yeah, so that's it. We got it working. Even in live, like doing again everything from scratch. No demo effects yet. And then we can have more, like you can have more advanced feature here. If you want to filter, you can search with this where close. If you want to filter from an ID, from a wallet, from a block to a wallet, this kind of from the transaction hash or from value. And you have also the ordering. So imagine that instead of wanting it in the late earliest one first, you want to the latest one. So you could say, I want to order, and I want to order by block descending instead of block ascending. And so I select block descending, then I execute the query, and then we got it there. So here we have the latest transfer with this transaction hash. And this, and we see it was a transfer done today at around 10 a.m. done by BDK. Yeah, I think that's good enough for today.
Amazing. Thanks for the walkthrough. Just one question here. When you were setting this up prior, were there any steps in that process where you had to troubleshoot a little bit that might be helpful for builders, as they're going through this process themselves? Anything they should watch out for? Yeah.
Barry, you want to talk about it?
We had a few. So basically, the API needs to be updated. I would say that's the biggest difference. And just make sure you update the schema. Just the endpoints, the schema, the API. It should work fine. It's just it didn't work on my machine because I like to play with Dockers too much. But I'll sort it out after the stream. but yeah, I think it's pretty straightforward. The nice thing about this is like you get an endpoint and you can just plug it into your app and just build really powerful apps with such a simple deployment. I think that's really cool.
Amazing. And the quick start page is just for the audience. It's docs.sqd.ai/SDK, right? Where they can find the initial kind of steps to creating the indexer.
Yes, you're right. That's exactly it.
Yeah, I'm putting it in the chat. So this way in the YouTube comment. And
yeah, I also shared the repo if anyone wants to play with it. I might need to skip the steps because I think we committed generated code, but you'll work through it. It's not too difficult, but it's just to kind of show, like, you make a few tiny changes to the template. That's like the most powerful thing. You make a few changes to the template, and all of a sudden you have access to all this incredible data. And same thing applies to most of the templates. you can use them basically as modules. Just rip some logic out, put it together, and build something very quickly that's custom to your protocol.
Okay, amazing. Cool. I mean, let's see how builders kind of use the data and dive in. When it comes to if they need any support on the SQD side of things, what's the, I guess, best channel for them to reach out if they do need to contact the team?
I'd say the developer chat. We can share it in a moment. And but if anyone wants to reach out to me, at Verified on Telegram, I'm more than happy to reply to anyone who messages me about anything technical. Yeah, maybe you're interested in building on SQD and you want to participate in the Boost program. It's also something that we're going to be expanding on. It's basically if you want to help us grow the ecosystem to fill the gaps that are missing between like the AI layer, which is very top level data, like signals and such, and the AMM data and the block level data, right? We have a lot of stuff we want to build as a community of builders, right? And we want to make sure that SQD is like a super powerful platform for just anyone who has a contract. Yeah.
Sounds good. I mean, as more builders start using SQD on the chain, we'll definitely, put some effort in gathering that feedback and then relaying it over so you guys can improve your products. So no, I think this was great. Thank you, Barry and Bertrand, for, giving an overview of, what SQD is and helping the builders to get started. And yeah, excited for the second segment of this, with the live project as well. So yeah, appreciate your time for today. And any closing remarks on your side before we close it off?
Yeah, I mean, would love to expand on it and do like a second iteration where we gather the NFT data as well as from IPFS potentially, just to kind of show the or maybe like a third-party API. That would be really cool to show the like the power of SQD, especially when it comes to social chains or just dealing with metadata. Yeah, it's incredible.
Cool, amazing.
I'm looking forward for the next session, as you say. Like, I hope it was not too complicated. But yeah, I mean, we wanted to try it before running it live to make sure that will be no fixing in public. But if there is some wish, I mean, we could also. That's what I like also, having the suspense of will it work or not. And so if we set the right expectation, like saying that instead of preparing it in advance and to be sure it works, could be also this kind of build in public where we don't prepare it in advance, and then we ask the LLM to see if it figure it out in public, if it works or not, and then to see how much time it would, how much time it would take, or what it can do in 1 hour, and it would be another way around. And because this way that seems more authentic also, like
yes.
seeing how a developer would do, like showing the real developer experience. And see that's also the difference between having a prepared demo and even sometimes I've seen also a recorded demo. So what I hate the most is the recorded demo. Because now you can even, I mean, when it's recorded, you can even shorten the time, or you can also modify it. And what I like is when it's fully live, and you see if there will be some network effect or some demo effect, or to show that it's really authentic and you really started from scratch. You run the command and it really does everything as you without even knowing if it will work or not. Because that's like the LLM. Sometimes it works and sometimes it doesn't. Even when you ask the same thing.
You just have to ask it, hey, I'm on live stream, can you please fix it? And then it's suddenly, like it activates. It's like, okay, I got you.
Yeah, we should try that next time.
I'm under pressure, please fix this.
That's part of
you are on live stream
process.
Oh my god!
From a true OG dev, no, it's great. Real-time feedback, right? So we can both improve our docs, which is ultimately for the better.
Pair programming with AI. That's why I feel what is helpful is when you feel augmented by the AI through the LLM, instead of delegating everything to the AI and not thinking anymore because the AI thinks for you. I feel that's a big difference also. That makes a big difference.
Yeah. Cool. Well, thank you again, both. Let's close it off. I think we did good on timing, given it was a live demo at the same time. So, I appreciate everyone for tuning in, and we'll catch you all on the next one.
Great. It was a pleasure to participate.
See you guys.
Thank you so much. Okay.
Thanks for taking the time.
Bye.